Hello everyone, I am Kartik Kumar Joshi and today's our subject is power system protection. Here we are going to understand that induction disk relay. There are many type of relays and the working principle of relay is when the passing current through the line is higher than some value, that means if the fault current is passing through the line, relay will operate and relay gives the signal to circuit breaker and circuit breaker will be open and fault will be clear. So here in the induction disk relay, that means there is one disk. So as shown in figure, there is one aluminum disk and there are two magnets. This is called upper magnet and this is called lower magnet. There are two magnets and between the two magnet we put a disc and the material of disc is aluminum. As we know that single flux can't rotate the disc, as we connect this as a single phase induction motor. So single phase induction motor is not self-starting because in the single phase only one flux is there, so we provide some arrangement to start this single phase induction motor. As similar as here, aluminum disc is not rotate with the single flux, means main flux. So here we provide some another winding called as a lag coil. Lag coil is provide the interaction of flux between two, means main flux and lag flux will interact with each other, and by that interaction the aluminum disc will rotate if the passing current is higher than the desired current. What does this line means? Let's assume that there is a 500 ampere oblique 1 ampere CT is that means the passing current in the primary side of CT is 500 ampere and in secondary side of CT is 1 ampere, and we set the value of 2 ampere. That means when the current passing to the secondary of the CT is increased about 2 ampere, our relay will operate. That means here we are going to explain this phenomena. That means here is one transmission line, here is one CT, if the CT is there, and here we are connect one relay, and this relay is 500 oblique 1. That means the primary side 500 ampere is passing and secondary side 1 ampere is passing, and our rated current is 2 ampere in the secondary side. That means if the current passing to the secondary is higher than 2 ampere, our relay will operate. What does it means? The current passing in the primary side is higher than 1000 ampere, so our relay will operate. So as we seen in the figure that when the current passing to the secondary of the CT is higher than 2 ampere, it is just example, we can let different example also. If the current passing to the secondary is higher than 2 ampere, then main flux and lag flux interact with each other and aluminum disc will rotate. Why we rotate aluminum disc? So that answer will give in the next figure. This is the figure of aluminum disc. As shown in figure of aluminum disc, there is one spring, there is one backstop, there is one moving contact and fixed stop. So what does this figure says about the working of aluminum disc? So one by one we can understand that there is one spring produce restraining force, and our moving contact is produce operating force. This phenomena will also we can understand here very easily. As we consider that there is a two block Let this example of two block. If the first one is A and second one is B, if the A block will provide force to B is F1 and B block provide to the force to A is F2. If consider that both force are equal, so what happen? No block is moving. But if the force applying by F1 is greater than F2, so what happen is both block are moving in this direction, and let's assume that B block is provide more force to A, so what happen? The moving direction of both block is in left side. So we conclude that if the force of one is greater than F2, then moving direction is in left side, and if the force is F2 is greater than F1, then moving direction in this side. As similar is happen in this figure. If the spring torque means restraining torque is higher than the moving contact, so spring will be not going to move this contact and our relay will not operate. But if the rated current is fault current is higher than the rated current, then the operating torque is higher than the spring torque, our moving contact will move and it will goes to strike with this, and circuit breaker will open, fault will be clear. So here is another figure of the induction curve relay. This is also be there, but our main focus on the understanding of the operating torque and restraining torque. So what is operating torque? The torque developed in the relay which tends to change the status of relay contact is known as operating torque. Status of change the relay contact means if the circuit breaker is closed, that means line carries the current, and if the fault is happen, our circuit breaker will open. That means it changes the status of our circuit breaker. That is called the operating torque, and operating torque is proportional to the flux, main flux and leg flux into sine alpha. This is the equation of operating torque. Next one, what is the restraining torque or spring torque? We can say that it is the torque which tends to oppose the change in status of the relay contact. That means if the passing current is not fault current, so no need to open the circuit breaker, and if this situation is there, the spring torque is higher than the operating torque, so no need to change the status of circuit breaker contact. So it is all about the induction disc relay. Thank you.